Chapter 2 Elements, Compounds and Mixtures. All materials or objects found around are either in solid, liquid or gaseous form and occupy space and have mass. In science, the term matter is used for all these materials. Chemically, matter can be classified as element, compound and mixture. In nature, matter occurs mostly in the form of mixture. Importantly, substances are required in their pure form, that is done by the separation of the components of a mixture by different techniques. The use of any particular separation technique depends upon the properties of the components of the mixture. Water, oxygen, hydrogen. Elements present in water as compound. The tea we drink is a mixture of several components: water, tea leaves, sugar, milk. Learning outcomes. After studying this chapter, students will be able to define elements as made up of identical atoms, classify elements as metals and non-metals on the basis of their properties, define compound and mixture and discuss the points of difference between the two, symbols of elements and molecular formulae of the compounds to represent their names as shorthand notations, separate different components of samples of some mixtures, discuss the reasons for opting for a particular technique for separation of components of the mixture. Important terms and their definitions. Element. It is a pure substance and the basic unit of matter. It cannot be broken down into two or more simpler substances by any means. Atom. It is the basic unit of an element which may or may not exist on its own. It is divisible into the nucleus at the center, which contains positively charged particles called protons and neutral particles called neutrons, and electrons revolving around the nucleus. Metallic elements. Metallic elements such as potassium, sodium, zinc, copper, etc. have luster, are malleable. It means they can be beaten into sheets, ductile, which means can be drawn into wires, and are good conductors of heat and electricity. Non-metallic elements. These elements such as carbon, sulfur, phosphorus, etc. do not have luster, are non-malleable, non-ductile and poor conductors of heat and electricity. Metalloids. Elements which show properties of both metals and non-metals such as boron. Noble gases. Noble gases are unreactive inert elements present in traces in air such as helium, neon, argon, etc. Symbol. A symbol is the short form or abbreviated name of an element which distinguishes one element from another, such as symbol of sulfur is S. Molecule. Atoms of the same element or different elements combine to form a molecule, which is the smallest particle of a pure substance which can normally exist independently and retain the physical and chemical properties of the substance. For example, diatomic molecule of nitrogen N2, diatomic molecule of oxygen O2. Compound. A compound is a pure substance made up of two or more different elements or atoms combined in a fixed proportion. For example, elements of hydrogen and oxygen form the compound water H2O. Chemical formula. It is the representation of a substance, element or compound by means of symbols. For example, chemical formula of sodium chloride is NaCl. Mixture. A mixture is an impure substance formed by combination of two or more pure substances mixed together in any ratio. Introduction. By now we know that things differ from one another because of their state of matter or the kind of matter they contain. Ice, water and water vapor differ from each other because of their states of matter are different. But an iron nail differs from salt because the kind of matter they contain are different. In this chapter, we are going to learn how things are composed of different kinds of matter. Things are made up of certain simple substances called elements. Two or more elements of different kinds combine among themselves to form new substances are known as compounds. Elements and compounds are single, pure substances. Many of the substances found in nature that we use are mixtures of one or more substances. Elements. When we heat or toast a slice of bread, it gets covered with black substance. This black substance is carbon. But if the toast gets burnt, smoke containing carbon dioxide gas and water vapor rises from the toast. Now we can break down this black substance or carbon in simpler substances. No matter how we treat the black substances, it cannot break into simpler substances. We therefore call this black substance carbon an element. Hence, an element is a substance that cannot be split or broken into simple substances by chemical means. By the term chemical, we mean methods that bring about a chemical change. For example, hydrogen, oxygen, nitrogen, carbon, magnesium, iron, aluminium, copper, silver and gold cannot be split into simpler substances by chemical means. The number of elements known at present is more than 100. 92 elements are naturally occurring and the rest are man-made. Majority of the elements are solids. 11 elements are in gaseous state at room temperature. 2 elements, mercury and bromine, are liquid at room temperature. Elements, gallium and caesium, become liquid at a temperature slightly above room temperature 303 K. Classification of elements. Elements can further be classified into 3 types of substances: metals, non-metals and metalloids. Metals. They conduct heat and electricity. They have silvery grey or golden yellow color. They are ductile, that is, they can be drawn into thin wires. They are malleable, that is, they can be beaten into thin sheets. They are sonorous, that is, they can make a ringing sound when hit. Gold, silver, copper, iron, sodium, etc. are all examples of metals. Add to your knowledge. Gold is the most ductile metal. 1 gram of gold can be drawn into a thin wire of about 2 km length. All metals are not hard at room temperature. Some metals such as sodium and potassium are so soft that they can be easily cut with a knife. Mercury is the only metal which is liquid at room temperature. Non-metals. They display a variety of colors. They are poor conductors of heat and electricity. They are not lustrous, sonorous or malleable. Oxygen, iodine, carbon, etc. are all examples of non-metals. Metalloids. Some elements have intermediate properties between those of metals and non-metals. They are called metalloids. Boron, silicon and germanium are metalloids. How are elements represented? Elements are represented by symbols, for example, H for hydrogen, C for carbon, N for nitrogen and O for oxygen. 2 letter symbols are chosen to distinguish between elements whose names start with the same letter of the alphabet. For example, Cl for chlorine, Ca for calcium, Mg for magnesium and Mn for manganese. The first letter is always written in capital and the second letter in small letter. The symbols of some elements are also based on their Latin names. Example, the symbol for potassium is K, first letter of Latin name kalium. The symbol for sodium is Na, first 2 letters of the Latin name natrium. The symbol for copper is Cu, first 2 letters of the Latin name. English names and symbols of some elements. English name of the element, symbol: oxygen O, nitrogen N, phosphorus P, sulfur S, calcium Ca, chlorine Cl, cobalt Co, aluminium Al, argon Ar, barium Ba, beryllium Be, helium He, iodine I, hydrogen H, boron B, fluorine F, lithium Li, magnesium Mg, neon Ne, silicon Si, zinc Zn. Symbols of some elements based on their Latin names. English name of the element, Latin name, symbol. Gold, aurum, Au. Silver, argentum, Ag. Iron, ferrum, Fe. Lead, plumbum, Pb. Tin, stannum, Sn. Copper, cuprum, Cu. Sodium, natrium, Na. Potassium, kalium, K. Tungsten, wolfram, W. Atoms of an element. As we know, elements are made up of similar kinds of atoms. But what are atoms made up of? An atom is made up of three subatomic particles: protons, electrons, and neutrons. Protons are positively charged particles. Electrons are negatively charged particles. Neutrons do not carry any charge. Protons and neutrons are present inside a small, dense and hard central core called the nucleus. Electrons move around the nucleus in fixed circular paths called energy shells. Compounds. Hence, based on the above activity, we can define a compound as: a compound is a substance composed of two or more elements chemically combined with one another in a fixed proportion. Or, a compound is a substance which forms when two or more elements combine in a fixed ratio by mass. Properties of a compound. The constituent elements of a compound cannot be separated by physical methods but can be separated by chemical methods. A compound is formed by chemical combination of two or more elements. Example: coal, carbon plus oxygen from air burn carbon dioxide gas. We cannot get carbon dioxide gas by simply mixing carbon and oxygen. They chemically combine to form carbon dioxide gas. Energy is either absorbed or evolved when a compound is formed. Example: coal plus oxygen from air, carbon dioxide gas plus heat. The properties of a compound are entirely different from the properties of its constituent elements. Iron sulfide has properties different from those of iron and sulfur. For example, iron shows magnetic properties but iron sulfide does not. Sulfur powder alone dissolves in carbon disulfide but iron sulfide does not. A compound is formed when constituent elements combine in a definite ratio by mass. For example, to form one molecule of water, the two elements, hydrogen and oxygen, combine in the ratio 1:8 by mass. Molecule. In some substances, atoms can exist singly, but in most of the substances, atoms combine to form groups called molecules. Molecule is the smallest particle of a substance, which can normally exist independently and which can retain the physical and chemical properties of the substance. H, hydrogen atom plus H, hydrogen atom, HH, hydrogen molecule. Atoms of the same element forming a molecule. C, carbon atom, OO, oxygen atom 2, OCO, carbon dioxide molecule. Atoms of different elements forming a molecule. Molecules of elements containing atoms of the same kind. Molecules of elements containing more than one atom of the same kind are represented by their symbols and form a molecule of that element. Element, molecule, atomicity. Hydrogen H, H2, 2. Nitrogen N, N2, 2. Oxygen O, O2, 2. Chlorine Cl, Cl2, 2. Bromine Br, Br2, 2. Iodine I, I2, 2. Ozone O, O3, 3. Atomicity is the number of atoms present in one molecule of the element. Molecules of atoms of the same kind: H hydrogen molecule, N nitrogen molecule, O oxygen molecule, Cl chlorine molecule, Br bromine molecule. Diatomic molecules: O ozone molecule. Polyatomic molecules: molecules of elements containing atoms of different kinds or compounds. Molecules of elements containing two or more atoms of different kinds chemically combined together are called molecules of compounds. Example: molecule of water, H2O. Elements: number of atoms of each element, molecule. Molecules of atoms of different kinds. Hydrogen, oxygen, H is equal to 2, O is equal to 1, H2O, water, HOH, water molecules. Carbon, oxygen, C is equal to 1, O is equal to 2, CO2, carbon dioxide, for CO2, HOH, water molecules. Chemical formula of compounds. Chemical formula is a substance, element or compound by means of symbols. It denotes the number of atoms of each element present is a compound. Substance, symbols, number of atoms in compound, formula. Sodium chloride, sodium NaCl, 1 atom of Na, 1 atom of Cl, NaCl. Lead bromide, lead Pb, bromine Br, 1 atom of Pb, 2 atoms of Br, PbR2. Symbols and valencies for writing a chemical formula. For writing a chemical formula, the symbols and the valency of the elements or radicals should be known. Radical is a group of atoms of elements. Example: sulfate, SO4. Basic concept of valency. Valency is the number of hydrogen atoms which can combine with or displace one atom of the element or radical forming a compound. Names of some compounds, their chemical formulae and the number of atoms of each element. Compound, chemical formula, elements present with symbols, number of atoms of each element. Water, H2O, hydrogen H, oxygen O, hydrogen 2, oxygen 1. Carbon dioxide, CO2, carbon C, oxygen O, carbon 1, oxygen 2. Sodium chloride, NaCl, sodium Na, chlorine Cl, sodium 1, chlorine 1. Hydrogen chloride, HCl, hydrogen H, chlorine C, hydrogen 1, chlorine 1. Ammonia, NH3, hydrogen, nitrogen N, hydrogen H, nitrogen 1, hydrogen 3. Methane, CH4, carbon C, hydrogen H, carbon 1, potassium oxide, K2O, potassium K, oxygen O, potassium 2, oxygen 1. Carbon monoxide, CO, carbon C, oxygen O, carbon 1, oxygen 1. Sulfuric acid, H2SO4, hydrogen H, sulfur S, oxygen O, hydrogen 2, sulfur 1, oxygen 4. Iron sulfide, FeS, iron Fe, sulfur S, iron 1, sulfur 1. Nitric acid, HNO3, hydrogen H, nitrogen N, oxygen O, hydrogen 1, nitrogen 1, oxygen 3. Magnesium oxide, MgO, magnesium Mg, oxygen O, magnesium 1, oxygen 1. Silver chloride, AgCl, silver Ag, chlorine Cl, silver 1, chlorine 1. Sugar, C12H22O11, carbon C, hydrogen H, oxygen O, carbon 12, hydrogen 22, oxygen 11. Calcium oxide, CaO, calcium Ca, oxygen O, calcium 1, oxygen 1. Ammonium chloride, NH4Cl, nitrogen N, hydrogen H, chlorine Cl, nitrogen 1, hydrogen 4, chlorine 1. Mixtures. If we simply mix iron fillings with powdered sulfur and grind them together, no heating, we obtain a mixture. We see and use many things in our everyday life which are mixtures of different things. Examples: soil is a mixture of sand, clay, pebbles, wood, etc. Rocks are a mixture of different minerals. Air is a mixture of many gases such as nitrogen and oxygen, etc. Hence, based on the above examples, we can say that when two or more pure forms, elements, compounds of matter are mixed together in any proportion, they form a mixture. Or, a mixture is formed by simply mixing together the components, elements or compounds. Characteristics of a mixture. A mixture has the following characteristics. The constituents of a mixture retain their properties. Example, a sugar solution will be sweet and watery. A solution of salt will be salty and watery. The constituents of a mixture can be separated by physical means. Example, soil and water can be separated from muddy water by filtration. Sugar can be separated from water by distillation. Actually, depending on the properties of the constituents, various methods are used to separate them. The constituents of a mixture may be present in it in any proportion. Example, a sugar solution may contain 1 spoonful per cup and another may contain 2 spoonfuls per cup, though both of them are sugar-water mixtures. The constituents of a mixture coexist without chemically reacting with one another. Example, hydrogen mixes with oxygen without reacting with it. A chemical reaction will take place only when a mixture of the two gases is kindled or when an electric spark is passed through it. Types of a mixture. Depending upon the nature of components that form a mixture, we can have different types of mixtures. Homogeneous mixture. Mixtures which have a uniform composition throughout are called homogeneous mixtures. For example, salt in water and sugar in water. Alloys and solutions are also examples of homogeneous mixtures. Alloys. Alloys are homogeneous mixtures of metals and cannot be separated into their components by physical methods. For example, brass is a mixture of approximately 30% zinc and 70% copper. Solution. A solution is a homogeneous mixture of two or more substances. Lemonade and soda water are examples of solutions. A solution is not necessarily a liquid containing a solid, liquid or gas dissolved in it. Solid solution or alloys and gaseous solution are also possible. Solvent and solute are the components of the solution. The component that dissolves the other component in it is the solvent. The component that is dissolved in the solvent is called solute. Generally, solute is present in smaller quantity and solvent is present in greater quantity. For example, we have a solution of sugar in water in which sugar is the solute and water is the solvent. Properties of a solution. A solution is a homogeneous mixture. Particles of a solution are smaller than 1 nm, 10 to the power minus 9 meter in diameter. Therefore, they cannot be seen by naked eye. Because of small size, they do not scatter light. Solute particles cannot be separated from the mixture by filtration. Heterogeneous mixture. Mixtures which contain physically distinct parts and have non-uniform composition are called heterogeneous mixtures. For example, mixture of sodium chloride and iron fillings, salt and sulfur. In other words, the components are not uniformly distributed and these components can be seen separately. Suspension and colloidal solutions are also examples of this mixture. Suspension. A suspension is a heterogeneous mixture in which the solute particles do not dissolve but remain suspended throughout the bulk of medium. Particles of a suspension are visible to the naked eye, for example, chalk powder in water. Properties of suspension. Suspension is a heterogeneous mixture. particles of suspension can be seen with the naked eye. Particles of a suspension scatter light passing through it and make its path visible. Solute particles in a suspension settle down after some time when kept undisturbed. The substances which make up a mixture are called its components. Example, sugar, water and tea granules are the components of tea. Components of a suspension can be separated by the process of filtration. Colloidal solution. A colloidal solution is a heterogeneous mixture in which the solute particles do not settle down but remain suspended. Here the particle size of the solute is between 1 nm to 100 nm. Colloidal particles cannot be seen with the naked eye but they scatter light, thus making the path of light visible. For example, milk and starch solution. Properties of colloidal solutions. A colloidal solution is a heterogeneous mixture. The particles of a colloid cannot be seen with the naked eye. Colloidal particles scatter light. Colloidal particles do not settle down when left undisturbed. Colloidal particles cannot be separated from the mixture by the process of filtration. Differences between a mixture and a compound. Mixture, compound. Mixture is formed by mixing of constituents in any ratio. Constituent elements always combine in a certain ratio. The constituents can be separated by physical process such as dissolving, filtration, distillation, sublimation, using magnet, etc. Constituent elements are not separated by physical process. Constituents retain their properties. Properties of constituents are completely changed. The composition of a mixture is not certain. It is not represented by any definite formula. Composition of a compound is certain. It is represented by a definitive formula. Types of mixtures and their examples. Type: homogeneous, heterogeneous. Solid: all alloys, example brass, copper plus zinc, steel, iron plus carbon plus manganese, and stainless steel, iron plus chromium plus nickel. Rice plus stone, sand plus salt, salt plus pepper, chalk plus sugar. Liquid: a solution of spirit in water, oil plus water. Gaseous: air, all mixtures of gases. Solid, liquid: a solution of salt or sugar in water, sand plus water, chalk plus water. Solid gas: smoke, a mixture of soot and air. Liquid gas: dissolved air in water, fizzy drinks, carbon dioxide dissolved in water, mist, droplets of water plus air. Separation of the components from a mixture. The components of mixture can be separated from the mixtures. We separate tea leaves from tea using a strainer. Your mother removes stones and husk from rice before cooking. Note: we should keep in mind some things while separating a mixture. To separate the components from a mixture, we make use of the properties of these components. Different components have different properties. Therefore, we cannot separate components of different mixtures using the same method. Methods of separation. To separate the components from different mixtures, different methods are used. Let's discuss them one by one. Separation of solids from solids. Handpicking. If a constituent of a solid mixture is big and visibly different, it can be separated by handpicking. For example, stones can be separated from rice in this manner. See figure 2.7. Plucking rotten grapes from a bunch is nothing but handpicking. For picking, forceps can also be used. Winnowing. Lighter solids are separated from heavier ones by winnowing. Farmers use this method to separate chaff, the covering of grain from grain. A mixture of chaff and grain is made to fall from a height. The lighter chaff gets blown away and the heavier grain falls on the ground. A wind helps in winnowing by blowing away the chaff more easily. Sieving. If a solid mixture is stirred or shaken on a mesh, particles smaller than the holes in the mesh pass through and the bigger ones remain on the mesh. Thus, particles are separated on the basis of their size. This process is called sieving, and the mesh usually fitted into a frame is called a sieve. Small and fine sieves are used in the kitchen to separate bran and other impurities from flour. The impurities remain on the sieve and flour passes through it. Bigger sieves are used at construction sites to separate stones from sand. Magnetic separation. Iron is attracted by a magnet, so if you move a magnet through a mixture of iron fillings and sulfur, the iron particles cling to the magnet. Sulfur is not attracted by a magnet, and so the particles of sulfur are left behind. Thus, a mixture of iron and sulfur is separated. A method such as this, in which a magnet is used to separate the constituents of a mixture, is called magnetic separation. Separation of insoluble solids from liquids. Sedimentation and decantation. Suppose you have a solid-liquid mixture in which the solid is heavier than the liquid. Example, a mixture of sand and water. If you allow the mixture to stand for some time, the solid will settle at the bottom and the liquid will remain over it. This process is called sedimentation, and the solid layer at the bottom is called the sediment. The liquid above the sediment is known as the supernatant liquid. You can pour out the supernatant liquid carefully into another vessel, leaving behind the sediment. In the laboratory, you may pour out the liquid using a glass rod to avoid spilling. The process is called decantation. However, if you have a solid-liquid mixture containing a solid lighter than the liquid, example, a husk-water mixture, sedimentation and decantation will not work. Decantation can also be used to separate liquids forming separate layers in a mixture, example, oil and water. Filtration. By decantation, a liquid is not completely separated from an insoluble solid. Filtration is a better method. You can easily separate a mixture of sand and water or one of the chalk and water by filtration. A circular filter paper is folded along its diameter into two semicircles. It is once again folded into 4 quarter circles. Now a cone is opened by holding 3 quarter circles on one side. The one is fitted into the cone of a funnel and moistened with water so that the filter paper adheres to the funnel. The funnel is fitted to a stand and a beaker is placed below it in such a way that the stem of the funnel touches the wall of the beaker. The supernatant liquid is slowly poured along a glass rod into the funnel. The solid collects on the filter paper whereas the liquid passes through it. The clear liquid thus obtained is called the filtrate. Centrifugation. If sedimentation is very slow, you can go in for a process known as centrifugation. A heterogeneous solid-liquid mixture is placed in a centrifuge tube, which looks like a test tube with a narrow bottom. The centrifuge tube is now placed in a holder of a centrifuge, and a similar tube is placed in another holder to balance it. The holders are rotated at a high speed with the help of a handle. After some time, rotation is stopped and the centrifuge tube is taken out. The solid gets thrown to the bottom and the supernatant liquid above it. The supernatant liquid is then decanted. Separation of soluble solids from liquids. Distillation. Separation of a mixture of two miscible liquids. Components of a mixture of two miscible liquids can be separated by using the technique of distillation. Dissolution and evaporation. This method is useful when one constituent of a solid mixture is soluble in a solvent, say water, and the other is not. Separation using a separating funnel. A separating funnel is a glass bulb to the stem of which is fitted a stopcock or a stopper. This apparatus is used to separate two or more immiscible liquids. Immiscible liquids are those which do not dissolve in each other. For example, oil and water are immiscible. Crystallization. While evaporating a solution, a stage comes when the amount of solvent becomes very little. This solution is called a concentrated solution. When it is allowed to cool slowly, crystals of the substance dissolved start separating. The process is called crystallization. It is used to obtain a substance in the pure state. Chromatography. Chromatography is a technique that can be used to separate the colored components of ink. Chromatography is done on a special paper called the chromatography paper. The basic principle used for separation in this method is that even though two or more substances are dissolved in the same liquid, their solubilities differ. Some solids may be more soluble than the other solids. Fast track. Chapter at a glance. An element is a pure substance that cannot be split or broken down into simpler substances. Elements can be classified as metals, nonmetals, and metalloids. An atom is made up of three subatomic particles, protons, electrons, and neutrons. A compound is formed when two or more elements combine in a fixed ratio by mass. The smallest particle of a pure substance that can exist independently is called a molecule. When similar kinds of atoms combine, they form molecule of an element. When different kinds of atoms combine together, they form molecule of a compound. Mixtures are constituted by more than one kind of pure form of matter known as a substance. The method of separating components from a mixture by hand is called hand picking. The process used for separating husk from grains using wind is called winnowing. The method of separating a mixture of various sized particles by passing them through a suitable sieve is called sieving. Separating components of a mixture by using a magnet is called magnetic separation. Filtration is a method of separating insoluble solid components from a liquid by passing the mixture through a filter. The process of converting a liquid into its vapor is called evaporation. Distillation is the method of separating dissolved salts or impurities in a liquid. Two immiscible liquids can be separated by using a separating funnel. Chromatography is the technique that can be used to separate colored components of ink.